Share screen. This session in particular has to do with the education and jobs and opportunities for professionals and students that want to get involved in this field. And so what I'm going to try to do is give you an idea of the type of subjects that need to be taught in this area, and also the opportunities that are out there for those that are interested on this field of space resources. Now, one of the first things that one needs to do is to have a definition of what exactly are space, what is the space resources field. And what it is, it's basically the practice of identifying potential resources in space, also being able to implement technologies to access and process resources to products, and finally, how to use these products. As you can see, these are the same steps that one follows on terrestrial resources. This is what we do to obtain resources here on Earth. Now, one important thing that needs to be, actually two important things that I would like to, 2 points that I would like to make, and that we always make to students is, first of all, it will tend to feel like this is a new field, just because of all the interest that this has gathered in the last couple of years. But in fact, it's important to understand that this is a field that has been going on for quite some time. And it is important because one needs to know what has come before we can make progress. This field actually started, at least in theory, in the beginning of the 1900s with Konstantin Tsiolkovsky in Russia, when he identified that there are many sources of materials that are there to help us settle the solar system. This was followed from the United Kingdom by Arthur Clarke, that actually mentioned that propellants can be obtained from, for example, water or oxygen on the moon. These were people that were scientists, but also in terms of science fiction of what could happen. But through the different decades, we have seen that this field has developed very quickly. In the 1960s, the very first meeting on how to extract resources from the moon was held at the very beginning of the travels to the moon by the Apollo program by the United States Space Agency. In the 1970s, a combination of science fiction and some science looking about different colonies in space that could utilize resources. In the 1980s, the first papers and books were coming out in terms of giving you an academic treaty of space resources, looking at all the variety of things, how to identify them, how to extract them, how to utilize them. A book on mining the sky and asteroids. In the 1980s was not just about the moon, but was about Mars and asteroids and settlements. And more literature started coming out, which is important to take into account. It was not until the 2000s that then practical systems started being developed, as there was a rush to go to the moon back then. And so there were different components, excavators, extraction systems of oxygen, of metals, sintering systems, robotic equipment were developed in order to extract resources from the moon. And in the 2010s is when we start seeing the very first companies that started getting interested in extracting water on the moon and also metals from asteroids. So it is important for anybody that starts to get educated in this field to know that there is a lot of material out there that one needs to review, to study, and not try to start everything from scratch. And so it's important for students to know that this is available and to know where we are right now. The other important point that it's important to tell students at the very beginning, or any professionals, is that the space resources is a little bit different what we have been doing in space for more than 60 years. Yes, there are unlimited elements of interest in the solar system, but what's important to note is that a resource has value by its utilization. It's only when we utilize an element that it has a value as a resource. If not, it's just an element of scientific interest or curiosity, like we have been doing for more than 60 years. And there are 3 important steps that one needs to follow in order to extract resources from space. And these are the following. First, you have to have a recoverable resource. That means you know the resource with enough certainty, geological, scientific, engineering certainty, that you know that you can go after it. This is what's called in the mining and the oil gas business a proven resource. Also that you know that you have the legal certainty, the economic certainty, and the environmental certainty that you can go after it. The other thing is that you need to have a technology to recover it. And third, and as important, you have to have a customer. There has to be a demand in order to make an element a resource. And so not only these are the three important elements for anybody that gets involved in the space resources field, but this is also the important guiding principles behind an education on this field. And one that gives you an idea of how multidisciplinary this is, because you have to consider many things in order to understand the field. So let's take a look, first of all, at very briefly at some of the resources that we're talking about, because there's a lot of misunderstandings of what exactly we're talking about when we look at resources in space. So very briefly, one of those is just the location. And we had a representative from the Luxembourg government just a few minutes ago talking about how Luxembourg got involved in SES, the company on satellites. That is a resource from space that gives us weather forecasting and global communications and global positioning systems. There's also resources on space stations. You have vacuum and you have low gravity that you can use to make products for Earth or for space. You also have a limited amount of sunlight and photons that can be used to not only power spacecraft, but you can beam it down to Earth in microwaves to have unlimited energy beamed down to our planet. These are the so-called intangible resources. So it's important to know that not everything can be mined, that you have things like these resources that can be utilized when we leave our planet. But once we start talking about destinations like the moon, the various asteroids, and even Mars on its moons, then we start talking about resources like minerals and metals, soil, volatiles, ices, and even gases on the surface, on the atmosphere of Mars that can be utilized if we go there and extract them. And these are just natural resources. We even have human-made resources, and that is all the space debris that has been sent into space for decades now, that not only we have to clean them up because it can be a hazard for many of our space assets, but also they can be recycled and they can be utilized as resources. So as you can tell, there's a lot of resources out there that any student, anybody that wants to learn about resources has to be aware of. And so this leads to the various activities that are conducted in space resources, what we call the space resources value chain, all of those activities that are needed from identifying a resource to utilize them. And so what I'm going to go through now is all of those areas that also need to be included in the education of anybody that wants to be involved in the space resources. Starting with fundamental research. Anybody involved in this field needs to know exactly what are the geological processes that gave way to resources on the moon, on Mars, and asteroids, on Earth. They're very different, all of them. What elements are we talking about, and the chemistry behind them? You need to know that fundamental research before you move to the next point, which is prospecting, exploration. Once you know what resources are out there, how much is it? What is the amount? What is the concentration? What is the distribution? How accessible are they? Are they economically feasible as compared to obtaining them somewhere else? And so that's a very important aspect that needs to be part of a space resources activity and of the curriculum of anybody studying resources. Once you know exactly what are your proven reserves in space, then you go to the space mining. Then you start excavating and drilling and extracting resources, the gases, the water, the oxygen, the metals, everything else, and all the technology that goes behind it, robotics and power and all that. Then what do we do with the resources? That's when manufacturing and construction comes in. How do we go from obtaining oxygen or water and making it into a propellant? How do we pave the way for roads and berms and landing pads? How do we construct habitats? How do we make tools out of this? This is a whole field within the space resources area. One thing that is important to all of them is the infrastructure that will be needed by anybody that does anything in space. and that is power. You need communications, you need transport that will have to be part of anything that we do in space resources. And finally, as important as all these technical aspects are what we call the soft disciplines, the economic aspects, the legal aspects, the social aspects that one needs to consider, just like we do on Earth. So as you can see here, you can see the whole space resources value chain and all of the topics that one needs to study in order to become an expert or somebody involved in this field. And here you can see how multidisciplinary is this field. Yes, you can be an expert in robotics. Yes, you can be an expert in mining engineering, but you need to know the economics, you need to know the legal aspects, you need to know the fundamental research, the geology behind it, in order to really understand this field. This is very different from what has been done in space before. Now we're introducing a lot of new disciplines that need to be learned besides your typical space systems engineering and orbital mechanics and everything else. And so, and knowing this, this is what we consider the important curriculum behind any education in space resources. Now, it's not just enough to learn about it in books or papers or to read about them through history or what's happening right now. It's also important to start seeing how is that we can adapt what we have learned about resources on Earth, but to do that in space. How we can do this in a vacuum, how we can do this in extreme temperatures, how we can do this under radiation conditions, under low gravity conditions. And so it is important to also for students of this area to also have a hands-on approach to space resources. Yes, learn the principles, but start developing the techniques and the tools so that once we get out and go to the moon or Mars or space or asteroids, we know the technologies that we're going to be using. So what I'm going to do next is give you examples of those type of projects in which students can get involved whenever they study this. In all of these aspects, in fundamental research, in prospecting, exploration, manufacturing, space mining, and the rest, so that you can get a feel of the type of project that students need to get involved in. So let's start by fundamental research. And how about just learning about the geotechnical properties of the regolith? It is important to know the properties of the regolith if you want to do manufacturing, if you want to construct things, if you want to extract anything. And so it is important to start getting involved in that type of projects. So why not doing experiments that you can do in vacuum chambers to simulate the vacuum, for example, of the moon or asteroids? Do it at very low temperatures, which is what you're going to encounter in those places. Also start working with simulants. These are ways to imitate the type of material that you're going to be doing, and then penetrating it and drilling into it and seeing what are the forces and the strength that you're going to be doing, and collect that data so you're ready by the time a company or a space agency wants to go and do this on the moon or Mars. In the area of prospecting and exploration, it is important to look at, for example, a prospecting rover on the moon, and looking at all the different things like autonomy and robotics. What does it need? What does it feel to moving in a soil that is very similar to the moon? Autonomous navigation, surface mapping, high resolution imagery, how to move around obstacles, and how to identify the places where you are. And once you start interacting with the soil, how is that you're going to drill, and how is you going to extract the different materials and be able to identify the different components? And so these are things in which students can start getting involved as they start preparing projects that will serve either space agencies or companies. On the area of space mining, for example, we're going to have to do excavation with an autonomous excavator. And so here is how are you going to control something like this? How are you going to excavate? How are you going to transport the material to the processing plant? How do you do this, minimizing the amount of lunar dust that you're going to generate, which is very important since it's very abrasive and it could be very detrimental. And so how can you do these operations and doing it with the type of soil that you're going to encounter in those places? If you want to extract the volatiles, the water, the oxygen, the hydrogen, the helium-3, whatever you want to extract, how do you go from knowing what those elements are in the lunar soil, and this could be a lunar simulant, and how do you can do experiments on vacuum chambers and heating this up so you can extract and get the rate of extraction of the various volatiles. Space manufacturing. Okay, how is that we can use the soil on the moon without having to bring any construction material and be able to make tools and parts and spare parts? How is that we can, for example, simulate solar energy and heat up the lunar regolith and not only extract the volatiles, but also at the same time melt it and sintering so that we can have paving roads, or we can make tools by 3D printing or spare parts without having to bring in from Earth. So these are the type of experiments that students can get involved in here on Earth. Same thing happens with space construction. How do we construct our habitats on the moon that we're going to need as soon as you have crews living there for weeks and months? How can you go from students just making things in 3D, in drawings, but then going into making it into a 3D printer that can use the materials very similar to that they're going to use on the moon and Mars, and make these autonomously and be able to construct those habitats to simulate what they're what they have been designing in just computers. So these are the type of projects that are important for students to get involved, besides learning about all the different aspects that I mentioned. Also, as I mentioned, there's subjects that need to be learned. Is this legal? How is it that we're going to go out and extract resources, knowing what we know from treaties that have been signed in the past, like the Outer Space Treaty of 1967, like the Moon Treaty of 1979. And there's going to be talks here on this forum today and tomorrow talking about those things. And not only know about those treaties, but what has been happening right now at the world level, at the United Nations level, but also learn about all the different organizations and groups that have been working on trying to establish a legal framework, and so that we can do things in space in a fair, in a responsible, in a sustainable way. And so these are the things that that students need to learn in this very multidisciplinary field. And as you can see, this is going to involve not just one country. We have to have the whole world working together, since this is quite a large undertaking. And so it is important to see how there's international interest now. There are space agencies around the world that now are interested on how to identify, how to extract resources, how to utilize them so that they can benefit from all this. So it's important to be in touch and have partnerships and collaborations that are needed in order to do this. And for students, what's important is that they can get involved in international events like this one right now. It's important to know what is being discussed in China right now on the Space Resources Forum. And so it is in the Space Resources Week in Luxembourg, which comes every year, in which many countries in Europe and around the world get together to talk about these issues. In the United States, there's the Space Resources Roundtable, also bringing professionals from the various fields to talk about this. In Australia, you got the Off-Earth Mining Forum. So these are the type of events in which students must participate, must present their papers and their posters, so that they start knowing who is who in this field of space resources. Same thing happens with competitions, student competitions, which are important if you want to develop your systems either by country, or you can partner with companies in other countries and participate in things like this. Here you have, for example, a robotic competition in the University of Adelaide, or the ones that are being held in in Colorado School of Mines in the United States, and by space agencies like NASA, in which students come in and develop their ideas. So all of this helps for students to learn about this new field. And so these are the important things, the important aspects that I mentioned, and the important hands-on projects in which one can get involved to get an education in extraterrestrial resources, which, as I mentioned, is a multidisciplinary endeavor. So that gives you an idea of the type of education that is needed in this field. So now the question is, all right, I have an education on space resources. What are my opportunities? Where do I go and work? What are the sectors that are going to need my expertise? And this is where we go to the next talk that was going to be conducted by my colleague, Christopher Dreyer, but he was unfortunately sick. So I'm going to cover for him on looking at business sectors, and opportunities in the field of space resources. If you get an education on space resources, where is that you can apply that? And how does it look this in the future? So Professor Dreyer has been thinking about this for quite some time. And in the last 4 years, he has developed a very simple way to look at the field of space resources in one simple diagram. And by doing that, you can identify the sectors, the activities, and with this, you can identify the companies that may be interested in participating. And as a consequence, what are the opportunities of those students that want to go into this field? So let's take a look at this diagram that Professor Dreyer developed so that you can see the whole field of space resources in a very unique and very simplified way. So what he has done is divided all of the different aspects of resources in one diagram. First of all, there are resources that will be utilized in space. This is what we call the living of the land approach. Things that you're going to need in space without having to launch it from Earth because it's very expensive, because it's very energy intensive. So if you need something on the moon, just use it there instead of spending thousands of dollars to send a tool to the moon. That's one part of the diagram. The other diagram is those resources that you may return to Earth once they become economically and feasible to do that. Companies have been talking about bringing metals from asteroids. So this is a totally different applications of resources. Ones are used in space, the other ones, you return them to Earth. But then there are different activities within this diagram that overlap those two. First is space mining. So these are the activities in which you drill, you excavate, you extract material, and you can use that material in space, or you can do it to return it to Earth. So this is the whole field of space mining that I also talked before. The other one is, what do you do with the resources? Well, you do manufacturing and construction. And sometimes these fields overlap. Sometimes you have activities that require mining that then you're going to manufacture, and then you're going to use in space or return it to Earth. And all of these activities is what constitute the field of space resources. So it is important to see it all as one one diagram, so you can see it how it works. Then let's now look at the activities that are feasible once you start looking at all these different aspects of resources. This is important because you're going to start looking at the different sectors that are developing very rapidly these days and where there are opportunities for jobs and for experiences for students. So let's take a look at some of them. For example, if you want to make propellant from hydrated minerals or ice on the moon, Mars, or asteroids, then you're going to need to mine the material, to extract it, to manufacture the propellant, and you want to use it in space. So here is one unique sector in which companies are getting interested on obtaining those elements, manufacturing them, and making propellant in space. You got space tourism. You don't need mining. You don't need manufacturing. You just need space. And you just need a place where people want to go and experience this. And this is happening as we speak. There are companies that are sending humans to space, and you can call it that a resource that will enable tourism. Habitats made out of regolith that will require mining or excavating the material, then manufacture, then construction, being able to make the habitat like I show in one of the movies. Oxygen made from Mars atmospheric carbon dioxide, like it is happening right now. There's right now an experiment on a rover on Mars extracting oxygen from its atmosphere, and you can utilize that on Mars if you wanted to. Spacecraft made in space. How about just utilizing whatever you have available on the moon or even in space or even from space debris and make spacecraft and large structures in space. Habitats constructed in underground spaces that will require just mining, not manufacturing, and do it in space. How about recycling crew waste? That's important. If you are in a space stations or you are on the moon, might as well use the waste from the crew and be as resourceful as possible and utilize it for a variety of applications. Now we go to returning to Earth. There has been talk about metals obtained from asteroids that can be brought to Earth if it becomes economically in the future. It may not be in the near future, but who knows? At some point, it may become economically, or we are mining too deep, or we're causing too much environmental disasters here, at some point it may become feasible. Manufacturing in microgravity. Are companies right now that are utilizing the low vacuum and low gravity in space to manufacture goods, like, for example, fiber optics in the space station that can be brought to Earth, or you can utilize materials and to make structures in space that can be brought to Earth. Finished goods, like the ones that I mentioned. These could be chemicals or medicines or any technology that can be developed in space that can be brought to Earth with a value added. Space solar power. How about just capturing the solar energy, beaming it in microwaves to Earth, and in that way collecting in rectennas and be able to utilize that energy here on Earth? That will be quite a good use of resources in space. Spacecraft solar power could be used to power a spacecraft. Space-based telescopes, we're already using that in terms of, this gives us knowledge of space, and it can be returned to Earth. GPS and communication satellites, we've been using this for quite some time, and the only use is the location in space, and you can bring down those signals to Earth. So this is an idea of some of the sectors that have been developing. You can call this ISRU, in situ resource utilization, like recycled crew waste, oxygen, both on the moon and Mars, propellants, habitats. These are things that are going to help space agencies to cut its dependence from Earth to do many things in space. Current practice, we already recycling crew waste, we already using space solar power, we already using GPS and satellites and telescopes. But what about commercial activities? The only thing that we have right now, it's a large, almost $400 billion a year industry, but the only thing that we have is GPS and communication satellites. And so you can already see the possibilities of how this is going to grow rapidly in the future, and the many aspects in which companies can get involved, and the many aspects in which people that are focusing and specializing on space resources will have an opportunity. And so it's important to see this, because this gives you an example of why companies are getting involved. From the very large companies, the aerospace companies that are looking into building spacecraft and landers that will utilize propellants made in space, the ones that are building those fuel depots in which spacecraft can refuel in space and move around. And not just the traditional aerospace companies, you also have the new space, the companies that are building new spacecraft in order to be refueled in space and be able to do a lot of the work that needs to be done up there. And this is just large aerospace companies. What about small companies that are now just coming up almost every month, that are offering transportation and also access to the surface? Some of them will get you to the lunar surface. Some of them will actually have a rover that will move around. Some of them will install power systems. And so more and more you're starting to see this in many countries, on these companies that try to do things on their own. So this is providing access and capability on the moon to do all the things that we want to do with space resources. So these are all places in which you can, with an education on space resources, you can be part and make a contribution. And not only that, if we look at this diagram that I show you, you can see companies that are already positioning themselves in all of the different aspects that I mentioned. You got companies like Astroscale and even Origin Space that are looking at how they can capture space debris or anything in space, and then give it to a company like Cislunar Industries that is going to melt the material and make propellant out of that, or structures. Companies like Honeybee Robotics that are going to drill and provide information and data about the resources that are in space, but also are thinking about extracting metals and other things. Company like Blue Origin concentrated on space tourism. Offworld, which is going to talk later today or tomorrow about how they have this idea of swarms of excavators that can serve to collect material and give it to any company that wants to use it. A company like Metallysis that is looking at how to extract oxygen, which is quite important because it's a large component of the propellants that you need. So applying technology from Earth, but using it in space. Icon, that is looking at constructing habitats and roads and berms. A company like Lunar Outpost providing rovers that are going to move around, or Made in Space looking at how to manufacture things in space, or Transastra looking at asteroids. This is just a few of the many companies that actually are doing this type of work and positioning themselves in all the different sectors that move around space resources. I can mention many more. I can probably, like the company Mana Electric, that is actually looking at providing power. They're looking at the infrastructure that all of these companies are going to need. So they're positioning themselves in a very unique aspect of providing infrastructure. Or a company like Orbit Fab. How are you going to refuel in space, and how that can benefit whatever you're doing? And many other companies that I can mention here. This is just one slide with companies that are small, large, big. Some of them have been working on equipment manufacturers, construction companies, oil and gas, mining industries, aerospace, small, large, and that are looking at positioning this. But I can fill probably 3 different slides or 4 out of all the companies that are being positioning themselves to work on this. So these are all opportunities for those people that will get an education in space resources. And as you can see, it's very multidisciplinary. They can work on large companies, space agencies, and at international level. And so this presents a very big opportunity for the future of space resources. And so what I have tried to do is give you an indication of the educational opportunities, the job opportunities on space resources. Space resources is going to be unique. It's like on Earth. They may not be a big discovery like a moon of a planet. They may actually be something that we don't see, just like on Earth. You don't know what your cell phone has, but you know it works. And so resources will be hidden, but will enable space exploration, will enable us to travel further, will enable us to stay on planetary bodies, will enable commercial activities. And so what I think space resources are doing is moving us from the adolescence of space exploration, what we've been doing for 60 years, into what I call the mature age of space. Now being able to do more and do it commercially and use the space for the benefit of humankind. And so with that, I would like to just pause right now and open it up for questions for anybody that wants to, that has a question about either education or of the different opportunities that are out there in space.
Hey, thank you, Hal. We have both the Zoom platform and the WeChat platform. Seems there are not many questions yet, but I myself have a question for you.
Sure.
Yeah. So, as we know, the Space Resources program in Colorado School of Mines has been about more than 3 years, right? How's the program going, and what do the students think about the program?
Yes, we have 3.5 years now in which we decided to focus specifically on space resources in all of the areas that I mentioned. I just wanted to give you a very broad view, but we cover all of these aspects, and we have had quite an interest. Right now, we have close to 130 students from 5 continents, from 22 different countries. These are professionals, which are in all of the engineering fields. We got people from mechanical and civil and electrical. We got economists, we got geologists and geophysicists. Everybody that is interested in getting a very multidisciplinary education. And after 3.5 years, they have been able to go out and work for aerospace companies. There's a lot of entrepreneurs, just like you, Tianhong, in Origin Space, that we have had close to 15 different companies that have been developed of people that see opportunities on how to put themselves on the value chain. So it has been quite successful so far. It's online so that anybody can participate from all over the world, because as I mentioned, this is an international effort. And I think it's very important to do this. So it has exceeded our expectations, because I think the interest on this field is quite strong.
Good to know. It's great.
Mm-hmm.
You just mentioned the students from various major background, right? Is there any kind of preferred background that you think if one student would like to join the space resource industry in the future, what background knowledge do they need to have?
Anything. What I tell the students is be good at what you are. If you're already a mining engineer, or if you're already a roboticist, or you're a geologist, be good at what you are terrestrially, and then apply that to resources. A lot of students ask, should I get prepared for this? I said, no, all you need to do is bring your knowledge. And what we will do is now adapted to what's going to happen in space. We're going to put you in a situation in which what you have done in your experience here on Earth, you're going to do it in a vacuum. You're going to do it at low temperatures. You're going to do it in low gravities. So it's just pushing your thinking in a different fields. So, and we need everybody. We need from economists, from roboticists, we need metallurgists, we need materials people, we need lawyers, everybody on these fields. So as long as you're good as what you have done during your college years, then you can apply it to space.
Okay. And I'm curious that you said around 130 students already in the program, right? What's the percentage of them that they really find a job in this industry or still in this industry?
Yes.
Or some of them just to go back to their original background. Yeah.
Well, that's a good point, because we have a lot of students that are already in aerospace companies. And so what they want to do, or other companies in which what they want to do is get the knowledge, because these aerospace companies are developing their own departments on space resources very rapidly. They all have now a department on space resources, so they go back to their companies. But many of those have gone, like I said, they have their own companies. They have gone to many of the ones that I mentioned there. And so luckily, all of our students that have graduated so far have found already a place to work. So that gives you an indication that it may not be a big field now, but it's growing very rapidly. So it is important to understand for students that this is not your typical aerospace. You're not going to become a satellite operator, which is probably hundreds or thousands of jobs. It's going to be going slow, but at some point it's going to become important. And the other important aspect, Tian Hong, is that this is opening possibilities to people that never thought that we're going to be involved in space. These are people that were working on extraction of materials, and now all of a sudden they have an opportunity to work on this.
Yes.
So it's a very exciting field for people that said, finally, I mean, I was in oil and gas, and all of a sudden I can help a space agency. Because one thing is, space agencies are great, are building rockets and satellites and communications, but they need a lot of help in terms of identifying resources, extracting, excavating. And so good opportunities for a lot of people in different fields.
Good to know. Yeah, thank you again. See our audience if there's any question coming up. I don't see any yet in this Zoom platform. Yeah.
Tian Hong.
Yeah. Yes.
Tian Hong. I have a question. Professor Abbud-Madrid, thank you for the talk. As you have mentioned that they are already diversified. I just try to make start my video. This is Professor Kefi Zhang from China University of Mining and Technology. And you have made the right point, given the program you have offered involve a large area, and the area is very diversified. And do you find any challenge in terms of the course offering, because of the nature of the course involve a large scope from quite different areas or disciplines? And I think it will be a challenge for the provider and also the student to learn so much diversified knowledge.
Yeah, that's
at least a 2 years program or 3 years.
That's a great point. We offer different things. We offer a certificate. These are for people that just want to have like 4 different courses. Master's degree, then you need to start getting the fundamentals, and we give them like 4 different courses, and then they go If they want to explore more of the mining part, they go into that. They're going to go to remote sensing, they go there, or power. And then you got the doctorates. Those are the people that really need to focus, like my camera, they need to focus on one single thing. And you're right, in all of them, we ask them to know a little bit of everything. And then we offer technical electives for them to, we have 5 different areas. One is remote sensing, prospecting. The other one is excavation, mining. The other one is power and energy. The other one is economics, legal. And so they can get the general feeling of the field and then go into these specialized areas, because you're right, it's impossible to learn about everything. So you know a little bit of everything, and then you start focusing on different areas. And yes, it's a challenge to offer those. So we constantly are adding new courses, because all of the departments in the school work with us, because as you understand, on a mining school, you have people that are working in all sorts of fields. And so you sometimes need somebody that is good in excavation. So develop a course in that, or a drilling, or you do a metallurgy. And so we constantly adding new courses to give you more specialized knowledge.
Do you actually work with other departments across the university or even other universities by offering different type of courses, such as the legal side, the law, because they are quite different from the engineering, science, and technology?
Absolutely. We are an interdisciplinary program, which means that we collaborate with all departments of the school. So what we do is, and we've been doing research on this for quite some time. So we have faculty that have worked on this for a long time. So for example, we go to the mineral economics department and we tell them, why don't you develop a course in terms of looking at economics of resources? Is it economic to make this? So there's a course there. We go to geophysics. We go to all petroleum engineering. We go to mechanical, electrical. We have faculty on physics. And so it's a good way to collaborate with departments. Sometimes in universities, it's hard to collaborate with departments, but we have been lucky because even faculty are excited about this. It's like all of a sudden, somebody that was teaching mining practices gets to develop something for space. So how is that you can apply this type of thing? So luckily, we have had the support of different departments and even other universities. If we don't have a certain area in which we're not experts, we bring people from other universities that can help us, so that the student really gets all of the different areas. But yeah, you need to be collaborator in a multidisciplinary effort.